CT school bus. There's no mountain high enough so we can climb them all. CT school bus. All the things you need to know about chem, so mysterious. And we're going to learn about nuclear chemistry. CT school bus. All the things you need to know about chemistry. CT school bus. Our suspensions are strong enough, just like hydrogen. You guys look tired today. Well, don't fret. Another morning, another field trip. Today, we're going to be learning about detection of radioactivity. Let's go! Radioactive materials contain unstable atomic nuclei that undergo spontaneous decay, releasing radiation. To detect this radioactivity, different instruments and techniques are used. Some methods of detection include a Geiger counter consists of a tube filled with gas and a metal wire running through the center. When a radioactive particle or radiation passes through the tube, it ionizes the gas, creating an electric current.
Is amplified and detected, producing a clicking sound or registering a count on the instrument. This method is often used for detecting high energy particles such as alpha and beta particles and gamma rays. Another way is the film and photographic plates.
The absorption of radiation causes a fog on photographic film. This is because photographic materials are absorbing the high energy. The more radiation present, the darker the area of the developed negative. This is very similar to how X-rays work. Substances excited by radiation can also be used to detect and measure radiation. Different substances react to different particles. For example, some substances give off light when electrons return to their lower energy states. These substances are called phosphors. There's a thing called a scintillation counter, and it works by detecting and measuring the flashes of light, called scintillations, produced when ionizing radiation interacts with a scintillator material, converting the radiation energy into light energy, which can be detected and quantified to determine the intensity and type of radiation present. Next thing that's important in this topic is radio tracers. The name is pretty self-explanatory. They're radioactive and they trace. Radio tracers are essentially radioactive substances that are put into a system or organism to trace and monitor specific processes. They are made of stable isotopes that have been artificially made radioactive by adding extra neutrons into their nuclei. These isotopes emit radiation. Radio tracers are able to mimic the behavior of naturally occurring substances. By attaching these radioactive isotopes to compounds that have any sort of activity, we can track and visualize their movement and behavior within living organisms, and even non-living things. Radio tracers present themselves frequently in diagnostic imaging techniques such as positron emission tomography or a PET scan.
I know this, my dad works the PET scans.
Oh, do you want to come up and explain this?
I guess so.
PET scans, a radio tracer, is administered to a patient by IV, and its distribution and accumulation in specific organs or tissue is observed.
This helps in identifying abnormalities such as tumors, metabolic dysfunctions, or areas of increased blood flow, providing valuable diagnostic information.
Also, radio tracers play a crucial role in scientific and research investigations. They enable scientists to study complex biological processes such as metabolism, receptor binding, and neurotransmitter activity in real time. By using radio tracers, researchers can better understand the underlying mechanisms of diseases, evaluate drug effectiveness, and develop new therapies. Radio tracers are injected into a patient. The compounds chosen are able to monitor blood flow, oxygen, glucose, metabolic rates, and other biological functions. After injection, the patient is placed in a big medical machine that can measure positron emission, which creates an illustration of sorts on a computer. The illustration is created when the radio tracer is decaying. As it decays, the emitted positron collides with an electron, producing gamma rays that can be detected by scintillation counters. This shading represents blood flow and activity, particularly for the brain. For example, this shows a normal brain. This has a lot of activity. This is mild cognitive impairment, and it has mild activity. But this is Alzheimer's disease. We can see that the center has very little activity, and we can see this from the scan. Go.
Besides blood flow, PET scans can also give us indicators about glucose levels, which can indicate cancers and heart conditions as well. As a tracer circulates through the body, it can be taken up by cells and metabolized similarly to glucose. Cancer cells and certain diseased tissues tend to have higher metabolic activity and glucose utilization compared to healthy cells. Scans detect the emitted positrons from the tracer's decay, and based on their distribution and intensity, creates a three-dimensional image of the metabolic activity in the body.
Class, you've done so well these last 3 days, but unfortunately, our bus is a no-show. So, we gotta walk home.